Okay, now we have recording. Okay, let's just go over, however, your question first. Or if you have no question, I prepare this hypothesis testing. Um, I like to share with you because usually we should have this one lecture for the in on-site class, and I would like to go over the important 4 steps how we do the hypothesis testing correctly. And actually, this is the most important, is highlight of the statistical course here. Because in the future, if you plan to go to graduate school to write your thesis or PhD program for dissertation, this is the skill we needed. We need to conduct one hypothesis testing to pass. So anyway, and if you say no, I just go to the work only. For me, when you needed to submit some proposal for some project, submitting together with hypothesis testing will be more powerful because that's using statistical process to show how significant your proposal. Okay, and so first, I'd like to see from you, wrote or
Hang
loaded.
on. My computer is off. Hang on. I'm trying to fix it because I
Oh,
can't
okay.
see your whiteboard. Hello?
Oh, you cannot see whiteboard? Yeah, no,
Yeah.
I'm going to share the whiteboard because
Okay, got it.
I had to turn off to do the recording. Yeah,
Okay, that's
so
okay.
that's fine. So let's share again. Share. Okay. Right. So now
I
can you see my whiteboard? We
Yes, I can see it.
Okay,
We can
very
see
good. I heard. Very good. Thank you. And so if you have any other question first, I can go over your questions. Otherwise, I'm like to present this one. How do you think? Do you have any specific question for me or from your chapter 9, hypothesis testing?
No.
No? Okay. Because the next, I think you were coming test 3. Yeah, test 3, including chapter 8, chapter 9. And our
Okay.
final exam only covers starting chapter 8, okay? 8, 9, 11, 12, 13, only 5 chapters. So I think we can do better because only 5 chapters. And
You said 8, 9, 11, 12, and 13, correct?
yeah, 8,
But the
9.
final, but the final will only be 11, 12, and 13, right?
No, 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 no. This is the final. Final will cover all.
Okay, all, but this
Yeah.
test coming up is only going to be 8 and 9.
The coming one, I was wrong. The coming one is only chapter 8, chapter 9. Two
Okay,
chapters
got it.
only. Yeah.
I'm writing it
Yeah.
down. Thank
Yeah.
you.
Then the test 3, test 4, one more is just chapter 11, 12, 13. Right.
Are you going to give us like examples like you did with the midterm so that way we can follow?
Yeah,
And then
we always have this midterm practice and final practice. So
perfect.
always a week earlier, I will post on the discussion board. Okay.
Okay.
Yeah. And
For the final,
mm,
I was just trying to understand because I know you sent the email a couple weeks ago and you said
mm,
something about dropping the
chapter 10.
dropping the midterm or final grade, depending on whichever one is the
Oh,
highest.
no,
So,
no, no. I'm talking about I don't drop a final. I
okay.
only encourage those students who didn't do well the midterm, right?
Hmm.
And for them to continue try harder because sometimes
Okay.
first time you taking this course and didn't do well the midterm, but your final appears much improved.
Okay.
Then, yeah, for example, your midterm got 80%, but your final got the 90%. I would take a 90, replace that 80. Okay.
Oh, so you only replaced the highest of the final exam
Yeah,
and then,
yeah,
okay, I
that's
got you.
right.
Thank you.
So pay
Thank you.
attention. pay attention to the final, okay? Do well on the final. So
Okay.
actually final decide your total grade now.
Okay.
Right.
Yeah.
But the
and
final won't have anything from the past, only 8, 9,
8,
11, 12,
9,
13.
11, 12, 13. Yeah.
Okay, perfect.
Only
Perfect.
5 chapters.
Thank you.
You're welcome. So focus on the new chapters now, okay? The coming test, chapter 8 and 9, then later 11, 12, 13, and we have final exam practice review, practice with that.
Code quad 4, but it's a full house. So
We can hear you.
Yvette.
Hello.
Yvette.
My
Yvette.
apologies. I thought I had my
Yeah, that's right. You have to mute yourself. Otherwise, we hear everything what you're talking there. Okay. All right. So let's go over the important part of the chapter 11. Okay. And chapter 11, no, not chapter 11. Chapter 9, hypothesis testing. And your course, I only require you to do the one sample hypothesis testing. But because chapter 10 is 2 samples. But I check out the other school, they usually only cover one sample for the elementary statistics. So we are going to follow that way. And if you know how to do chapter 9, you will be able to do chapter 10, okay? Naturally, later on, you need to do something more. Especially in this class, you will learn how to use technology to get the harder part. This is some part of the process here. Traditionally, we need to use algebra formula to compute and kind of complicate and easily to make a mistake. But if you learn how to use TI 8384, it's very simple and easy. Okay.
Yes, just plug it all into our computer.
Yeah, you just need to input the
calculator.
data. Plug in the data, but you still need to understand the concept, right? For you to plug in, and calculator will do for you those complicated algebra formulas, and you don't make a mistake on that. Okay, so let's start from this example here. This example, I posted at STAT 1000 discussion board as activity questions. And I think it's good that you need to totally understood what's the process of the hypothesis testing. Then later, when you see any other example or questions, it will be easily to understand how to answer it. Okay. So this one is an example showing that according to the survey, the data provide the evidence that 8% value inaccurate at the significance level of the 5%. It is believed that nearsightedness affects about 8% of all the children. In a random sample of 194 children, 21, they found that 21 out of 194 are nearsighted. So given this data here, we are going to do something. The point estimate for the nearly normal. Okay. Let's just explain something more than what we need. So step 1, the major part of this problem is to try to draw the conclusion. Do this data below provide the evidence that the 8% of the value is inaccurate, okay, or is it true? We don't know yet, so we need to do the hypothesis testing, okay. So that 8% is a kind of survey from the past, okay. So when you work on the hypothesis testing question, the noise is coming from my computer, huh? Okay, sometimes stop. Since yesterday, it makes a noisy on my computer like that. Sorry. So we can see this problem involving with 8%. When you see the percent, you must tell yourself, this problem related to the proportion problem, right? proportion problem, we always use a percent. So proportion problem, the notation to do the hypothesis testing, the reason we do the hypothesis testing, we are using some simple evidence and to find out is this apply to whole population. And that's what we are going to do. So you need to start with your notation correct. And the notation for population proportion is a small p. Oh, this is not small. Small p. Okay. Small p. And no hypothesis. We always put the equal. Okay. Just like when you go to the court for the criminal case there, the judge have to assume this criminal we don't even call the criminal, we call suspect, right? The suspect is innocent from the beginning. Then we have those jury to decide and judge draw the final conclusion to determine who is really committed a crime or not. So hypothesis testing look like that. At the beginning, this is no hypothesis. We call HO or H0. The modern some book they use H0, H1, can use a computer binary 0 and 1. But traditionally we usually call no hypothesis, use O there, HO. And alternative hypothesis, we use A, is coming from alternative. And when we conduct a hypothesis testing, we always put the two hypotheses there. One is usually is state equal something, okay? Existing claim there. Then alternative, HA, is always against the first one, always against the first one. Remember that, okay? So no hypothesis, you can just put the equal, okay? I know some older textbook, they may put the less than or equal, greater or equal. That's very confusing to the student. So the recent textbook, the author, they always only put the equal only, okay? Because equal is good enough. So I will put it what? The percent. Another percent can convert into the decimal. So that the 8% given in the problem, I will change it to 0.08. 0.08, 8%. Okay. Because change it to the decimal is easier to compute with our calculator or computer software. So first we assume, yeah, in the past we say 8% here, okay? 8% of the children will get a nearsighted problem. Then the alternative, you need to do this, P, and to against that equal 0.08, because the problem said we are going to testing providing this 8% is inaccurate. That means it's not equal to the 8%. So if the meaning is not equal to, you will put it here not equal to, okay? And not equal to is 100% against that equal, the no hypothesis. So I will put the not equal to here. And I don't have the notation of the not equal to on the whiteboard, so I need to put it like this. That the slash supposed to put in the middle of the equal sign, not equal to 0.08. So this is right at the first step we always do. Then you may say, because in the past I saw some students say, I'm so confused how to write that alternative correctly. No hypothesis, I know, I can just put the equal, no mistake. But alternative, sometimes I saw the book say greater than, sometimes put it less than, sometimes you had to put another equal to. So the reason I put another equal to, because when I reading the statement, I saw the beginning here, inaccurate, right? This one is inaccurate. That's the keyword I saw it, right? Inaccurate. Another equal to 8%. So that's why my alternative, I put another equal to. And some questions from your homework or quiz or the coming test here, or the final exam, if they use the word that some value here from the past, some value given from the population here is greater than, okay, this value from our sample evidence, we find out actually it's greater than existing 8%. If they put a word of the greater than, then you need to put a greater than in alternative. If the problem use the word of the 8% value is less than, okay, when you see somewhere it shows less than, and then you put a less than, okay. So reading the problem is so important. Always got some important keywords to remind you what you set up your hypothesis statement, okay? Especially alternative. You're always reading from the problem to decide to put the greater or less than or not equal to, because we only have 3 choices to put here: greater, less than, or not equal to. No hypothesis. You can just put equal, nothing wrong. Okay. So that's the statement. You have to learn how to write it. Step 1, actually, we need to write the claim. Claim what we are going to do. Okay. Existing claim and alternative claim. Okay. Then step 2, and one more thing from the step 1 here. When you put the P not equal to some value they give to us here, 8%. You should remind yourself not equal to imply 2 meaning. Could be greater or less than. Okay. So from this step here, actually, you got to understand this is a two-tail test. And the two-tail test means could be right tail or could be right tail. We call right tail. Right tail. Or left tail test. So in hypothesis testing here, we have this right tail test and a left tail test or two tail test. And this problem got the 2 parts because not equal to we put in the, on the part of the alternative. And in algebra, when one number is not equal to the other number, that's imply the first number could be greater than the second number, or first number is smaller than the second number. It's an application from algebra there. Okay, so that's why you have to understand. Could be right or could be left. 2 meaning here. So understand the concept. This one is for your concept. Okay. Let me put a parenthesis. We don't need to write out here. Then the step 2, what the step 2 we do? Step 2, you need to calculate the test statistic, okay? And test. Remember, we have seen this word, I think it's in chapter 1, beginning, okay? When we started learning some terminology, this is word of the statistic without the X behind. Now we are applying now. Statistic means the measurement from the sample. And its characteristics from the sample data we have. Whatever sample data, we measure it and find out the result from the samples. Could be sample mean, could be proportion, sample proportion, and could be standard deviation. This is also statistic. Any measurement coming from the sample data, we call statistic. And so step 2, we are going to test this, right? Statistic, testing our evidence to support our claim or reject our claim, okay? So I put a parenthesis here. Here you should try to use your TI calculator, one prop G test. And TI-83 also provided it. Or TI-84, both calculator got this one prop G test. So if you look at it, you have calculator in your hand, on your hand now, you should take a look, okay? And how can I find out this test here? You just go place on stat, and move on to the test, okay? How you find it? When you hit the calculator, stat, and you need to move on. Then move to the right side, you will see test, and the test there, I believe it's the first function. Okay, you hit the enter. When you come to the right side test here, you will see option 1 is a G test. That's a G test. And that's for the mean, not for this problem here. For this problem here, we need to go to, because the percent problem appears there. So you need to go to number 5, option 5. Okay, and go to the option. Option 5, you will see 1 prop G test. This G test is designed for the proportion. Okay? So the option 5 is the right program you need to use. So hit enter, confirm. Yes, I want to use this one. So when you choose this one here, you will see the first question is asking you need to enter the data now. And you can see this notation shows PO, like a PO, right? Or P0 is ask you to enter the proportion number, what is given to us here. That's
0.08.
yes, so we just need to put that other number given to us, 0.08 or 0.08. Sometimes when I omitted that 0 there, some students read it differently. So I usually like to put a 0.08, remind you. And the next one, so that the PO is a proportion from our statement from the null hypothesis, okay, same number. Then X, what's the X? X is success number, okay? And success number is what we expect to happen here. So when we read the problem, you can see in the sentence here say, in a random sample of the 194 children, that's the sample. And that's our evidence here, okay? And 21 are nearsighted, 21. So we are checking out the nearsighted children. So you just put another number, 21, okay? Then the next one is N. N is sample size. So Paul say 194. I just enter 194, right? So let me enter my calculator. So X21, N is 194. Then you see this one here, say this one is ask you, pop here is ask you to decide this is a one-tail test or two-tail test. And one-tail test, we have right tail or left tail. Now you know. So not equal to is a two-tail test. That's the first one. And for this question here, we are doing this one. We are doing not equal to. So I will choose the first one and make sure highlighted on that. Because if your calculator has been used for something else, maybe it's flashing on the other choice here. You need to move back to here and hit the enter.
Yeah, how do you put the right one then?
You just move to there, move
Okay,
to
got
not
it.
equal to. Use your arrow key, arrow
Not equal to.
panel. Move to this
Okay.
one here and hit the enter. You need to hit the enter. So they don't go away. If you didn't hit the enter, it will go away again.
Okay. So the next one is blue. The color, is it always blue? I don't
Oh,
know.
that one you don't need to worry about. That one just
Okay.
actual sense. You want to print out your result, so you can choose the color. We don't need that. So just go down, go down to calculate and hit the enter. Enter, then you're done. So you don't need the algebra formula. Algebra formula of the step 2 is kind of complicated. You need to use the algebra
Yeah,
formula.
no, this is good. You give it to us here. So we don't have to
Yeah. This is the best way. Then you will come out the result. Hit the enter. And no, you go to calculate. Skip to go to calculate. Then hit the enter. Okay. Then you will obtain the result already. We give you G equal something. That's our test statistic. Okay. And usually we round it to 2 decimal because traditional table, they always print out the 2 decimal for the G score only. Only
Yeah.
special
Can
one.
you put that in quotations right there, Professor?
What?
Two decimals only.
Oh.
Yeah, put it in quotation.
Yeah. But your homework exercise, sometimes they want the 3 decimal, 4 decimal. You just follow the instruction. But usually 2 decimal. Okay. You probably didn't say anything. You can just round off to 2 decimal. Round off. Okay. Regular rounding. regular rounding pre-algebra formula. Just go to the third one and compare to 5, right? Happen to this third digit is 0, so you don't need to worry about. Just round off to 2 decimal for the G score. Okay, so we got the test statistic. So this is the one. So if you work on your homework, you will see some question just ask you the test statistic. Then that's it. That's a 1.45. Okay. Then some other question could ask you is the next one now. Important one. Next one. Step 3. Okay. Let me move up. Oh, how come? It's kind of, yeah, we can move, right? Okay. So now I move up for you to be able to see there. So step 2, we done. Just use the calculator to get it. You don't need those formula from the book. Then step 3, okay. Usually we try to find the p-value. Okay, this one. This is the important one, p-value. We came back again. And I want to just go up. Okay, p-value. P-value. P-value, I think I explained last time already. P-value is the probability, the chance we bring our test statistic go to the right side, to the end of the curve, the normal curve, to the right or to the left, dependent right tail test. Right tail test is go to the right side. Left tail test is check something, we go to the left. And two tail test means could be go to the right or could be go to the left. Depend on our test statistical result. And from the step 2, we can see our test statistic, G, is positive. So our evidence shows on the right side because we are using now our concept, change that everything into the G score, right? Any data score into the G score. And the G score, the center position for the mean is 0. G as 0 is in the middle. And positive go the right side. Negative go the left-hand side. And negative means that the score is lower than the mean. And positive score, all the score means those data is higher than the mean, greater than the mean. So that's why there's a positive and negative G-score tables. So understand that we can see our G is positive. So I know if we need to continue to go to step 3 to do the testing, find out the conclusion, you need to use the p-value. And p-value is the easier one than you use the critical value. Okay. So p-value is used. What is the p-value for the hypothesis test and conclusion for the rejection? Usually, question will ask you this step. Our final exam, some final exam problem, I will just ask you one step like this. What is the p-value for this hypothesis testing? And what's the conclusion? Your rejection here, okay? So step 3.
1.470, right?
Yeah, you can see from your calculator there, right?
Yeah.
The calculator right below our G, it will give you a small p equal. And that small p is the one in our book called p-value, okay? And the p-value equal, like you said, 0.1469 and another 9, right? Usually I will go to the 5 decimal. And from here, I round off the 4 decimal because usually problem asks us to round to 4 decimal here. So we would start from here, point. The 5th decimal is 9, so I will go up as 1 unit, adding to the 4th decimal, so 9 plus 1 becomes 10. So it will become 0 there. And carry one more to the left, so become 0.1470. That's the rounding. Oh, I put it too many zeros. Okay. So after rounding, you will see into the 4th decimal become 1470. And that's the final answer. That's the final answer. Okay. So what's mean this? And we need to understand more than this. Okay. So if the p-value, you got the p-value, that's good. At least you know you can use this value to compare with alpha. Alpha is a significance level. And if you remember that at the beginning, we have statement here saying, go down, say, we are going to compare significance level 5%. So your p-value is going to compare with this 5%. Okay, 5% is I will draw something here to show you what it means. And look like I cannot do anything here. Let me see. Yeah, I can do something inside. So let me draw, schedule a bell curve here. And we come out the test statistics 1 point something. Let's say somewhere here. Okay. Here's 1.45. And you can see 1.5, 1.45, this is test statistic. This is the evidence of our test statistic follow our statistical algebra formula to show how far away from the mean. Mean is in the center here, okay? And the G-score is 0, compare here. So here is the position of the, actually, when we compare to our null hypothesis, it's our null hypothesis we are comparing, okay? Is this PO? On your calculator, use the PO. It's the same number of the null hypothesis, P equal 0.08. The position of the 0.08, okay? As a proportion is 0.08. But when we change it to single, the G-score is kind of in the center, in the middle. So our test statistic is 1.45. That's the evidence of what we collected from the 194 children. And the area bounded by this test statistic, this area, I try to put the red color, is the one we call p-value. The probability that can bring our test statistic go to the extreme of the curve there, p-value. So if you understand the concept, now it's much easier for you to accept the rule, because we have rule here to do the comparison in the step 3 using the p-value, and we are going to compare with alpha. And remember, alpha from the Greek, this means a significance level. And the problem always will tell you what's the alpha. So it's 5%. 5% is a common number we use all the time, okay? 0.05. It's kind of like allowance to be something not from related to original. So this 5% is kind of some allowance that for us to compare to see this evidence is strong enough to reject our original claim. And our original claim is this, no hypothesis. The proportion of the children who got near-sighted is 8%. Okay, that's accurate. 8%, exactly equal 8%. So we are going to decide, can we reject that or not, using our sample evidence. And sample evidence is 1.45 of the G-score away from the center, okay? But you can use the p-value. Use a p-value is area compared to significance level. Significance level is also area. So this number we came out kind of bigger than 0.05, 0.1470, right? 147 and 0. Okay. So we got the p-value so big, bigger than the alpha. Okay. Alpha, let me use another color. Alpha is 5.05 only, so must be the end of this area only. Small area to the tail side. And usually what is bounding this alpha is the one we call critical value, because you can see some problem may ask you to find the critical value. So critical value is learning from the alpha, kind of some standard we set up here to criticize that our evidence is strong enough to reject or not. Okay, so understood that there's using a graph, you can see p-value where it is and alpha where it is. Okay, and you can see 0.05 is a smaller area here, significance level. And obviously, we can see that the area of the p-value is bigger than the alpha. Okay, so that means, what does this mean here is showing our evidence test statistic 1.45. Test statistic, remember, is 1.45, the G-score. It's kind of close to the center, close to our null hypothesis, our original statement as a 0.08 position here in the center here, okay, in the center, closer, and did not go to the significance level. Therefore, it's not enough evidence to reject our claim, okay? To reject our null hypothesis, this claim here, our evidence got to be far away from our center. And our standard is that we have to check our test statistic falls in this area or not. In the area corresponding area here as a significance level. So, in other words, our test statistic got to stay far away and belong to area of the alpha there. Then we can reject it. Right now, our test statistic, this p-value, the chance is bigger than that one. That means our position is still close to our null hypothesis. It's not far enough to qualify to reject that null hypothesis, because to reject, you have to come to this area of the alpha. Alpha significance level is the one we decide that we can reject or not reject. Okay, so look at the graph, then we can come back here to write out the statement correctly. So I don't want to do this. How come you don't want to go away? Erase. Okay, so now I don't want to use this anymore. Okay, you don't allow me to move anything. Take away. Okay, so now I can come to look at this. So I can move up. So I will move up. Okay, so now come to step 3. Look at the graph we did earlier. We did some analysis. Now it's a time for you to think about, okay, since our p-value is bigger, right? I take the p-value compared to the alpha significance level, 0.1470 is greater than the 0.05, the significance level, okay? So the rule, make it easier. That graph, I just try to make sense for you, but you can just follow this rule. We have rejection rule here. You can just apply it. And by the time when you do several times, you will understand, oh, that makes sense now, okay? So this is the rejection rule. Wow, so hard to write with a mouse. So rejection is try to reject the null hypothesis, okay? We apply rejection rule. Let me see, can I use this to write? Okay. I'm going to write inside much easier. So what's the rejection rule? You just need to remember this rule. If p value greater than alpha, I don't have symbol here, so I'm going to just write alpha is greater than the alpha, then reject. No, I'm sorry. Use the less than is easier. If p-value is smaller than the alpha, then you can reject. You can reject null hypothesis. That's the first hypothesis we did. This is the important rule. We are going to apply this rule starting in the chapter chapter 9. Actually, chapter 10 that you don't need to do it. Chapter 9, chapter 10, chapter 11, chapter 12, until the end, chapter 13. We always apply the same rule. If the p-value is smaller than the alpha, then we can reject. But look at this example. Our p-value is greater than the alpha. So just try to memorize one way, okay? And the other way will be the negative way, right? So in other words, if the p-value is greater than alpha, we fail to reject here. So this is the rule, okay? Always remember this rule to apply everything. Then I'm going to write down the reason. Since our p-value, what we got is 0.1470, which is greater than the alpha 0.05, right? So we fail to reject the null hypothesis. That's what you need to write out, okay? And if you take this as a rule for you, actually it will make it easier in your life now, okay? You just need to remember p-value smaller than the alpha, we can reject. Otherwise, we cannot, right? So this problem we had is greater than 0.05, so we fail. We fail, or you can say we do not reject the null hypothesis. So that's step 3. You need to be able to show that. Then when we come to the step 4, you have to write the final conclusion and address the original claim, okay? And avoid using the terminology or symbols because the hypothesis is a process. We didn't want to write our final statement using the notation. This step is supposed to read your report. For example, like when I was in the PhD program, I have to report to my advisor, and but all my advisor, they are statistical expert. That's okay. But we are talking about that when you work for some company, you have to submit your proposal to some CEO or your manager, and that manager or CEO, maybe they left school for a while. They forgot what is hypothesis testing, but what is this this keywords we are using here, and they want to understand. So that's why conclusion, you cannot use those kind of terminology or symbols here. Okay, that's kind of rule we are following here to help the people to understand your statement. So what I do, I will just write. I think I need to open another one. Be able to write out. So I'm going to write out here. My final conclusion. Okay, remember, we are no hypothesis is not 8%, okay? And alternative is not equal to. Since we fail to reject the null hypothesis, now you have to use your logical sense. We cannot reject the first one, okay? So if you cannot reject the first one, that the null hypothesis, we cannot come to support the alternative. It just cannot go down anymore, okay? And remember, the null hypothesis is saying that the proportion is correct, is equal to 0.05, 8%. But alternative is saying not equal to, okay? So you can write this one here. Just use our result from the step 3. Since you can write a final conclusion. There is, we had to answer that, okay, there is not enough. Usually people will use enough or use sufficient. You can use either word, it's fine. Sufficient evidence. Use evidence to reject no hypothesis. And no hypothesis means what? To reject the no hypothesis. And remember, we don't want to use terminology. So there's not enough or sufficient evidence to reject the claim that the proportion of 8%. We cannot reject that. Okay? Not enough of the evidence. To reject, our evidence need to go down to the significance level area, but we did not. We are kind of still very close to the original no hypothesis. So there's not enough or sufficient evidence to reject the claim that the proportion is 8%. The proportion of the 8%. And for this problem, actually you need to address something more, right? Because this problem is asking you, does data indicate 8% is inaccurate? Okay, so you need to answer that. Okay, some CEO, they left the school for a while, they forgot all the notation. They will just look at your last step only. And the last step they will see, they will check, does data saying the same thing inaccurate or accurate? They will watch that one. So you need to continue answer, right? I think I need this. Let me see, can we make this bigger? Wider for me to get more room. Okay, I think so. And then I will add more. I will say the data. The data so there's not enough evidence to reject our claim of the 8%. Okay, so the problem also asks you, does the data is inaccurate? So you needed to say there is not there's not enough or there's not sufficient evidence to support that the data is in.
You forgot the A.
I forgot the A, yeah. There's remember that the statement is does this data and conclude, we can put a conclusion, okay? And there's not sufficient evidence to support the claim that the data is inaccurate. So some people, they forgot statistic. Maybe they just read your last sentence here. There's not sufficient evidence typo. There's not sufficient evidence to support the claim that the data is inaccurate. Okay. So, or you can just say, we conclude that the data is not inaccurate because we cannot reject the null hypothesis. Okay. So that's why the data, we cannot support that the data is inaccurate. Okay. Maybe we should just put a conclusion. simple way. We conclude that the data is not inaccurate. Because 8% you cannot reject. There's not enough of the evidence. So we conclude the data is not inaccurate. Okay. In other words, the data is accurate, right? But sometimes when we answer the question, people just look at whatever they make the question there. You just have to follow their wording. And the wording, their questions, does the data inaccurate? So you need to use the same word here, right? So that will make it much clearer for people to understand your conclusion, okay? So this is the one complete hypothesis testing for the proportion problem, okay? And if you have any question from some sample mean question, sample mean hypothesis, you can ask me now. And because there's something I need to remind you too for the population mean testing. Population mean testing, we have to be careful two things. One, you have to watch out if the population standard deviation sigma is given or not. If sigma is given, you will use a Z test, okay? I think I better write down this for you. Okay. So this example is for proportion. And in this chapter 9, we still have another testing, two testing you needed to know. One is the testing the population mean. If sigma is given, that means the population mean, okay? If sigma is given, you have to use testing population mean. One, if sigma is given, you need to use G test on your calculator. That's the first one, okay? When we go to the stat test, and when you come to the test there, the first test on the top, that's the one you need to use, okay? G test. And second thing you have to watch out is if sigma is unknown. The problem didn't give us any sigma, only give the simple standard deviation, small x only. Then use t-test. And t-test is the second test, okay? So it's option 2, that's a t-test. And the procedure to do is to follow the 4 steps, same thing we do. And you can use the same p-value rule to apply to the g-test, the t-test. That's applied to the population mean hypothesis testing, okay? So I hope this reminder will help you to do all this one correctly. And one more thing from the chapter 8. Have you discovered any questions from chapter 8? In chapter 8, we have sample size problem. That's the common mistake all the time. You have to remember sample size problem. You always have to round up to the next whole number. It doesn't matter your calculation come out 0.01 or 0.05, very small decimal, you cannot drop out. You need to round up as one whole unit of the sample, okay? Chapter 8 is, you have to be careful with that. That's the common mistake all the time. And chapter 9, you can follow this example to do your 4-step hypothesis testing. And exam time will either ask you the step 1 or step 2 or step 3 or step 4. They kind of break down for you to do it and to answer the question. So this will be the good example for you to follow. Okay. And just remember, when you come to do the testing of the population mean, we have two tests, G test and T test. How I decide to use depend on sigma. Sigma is given, I use G. Sigma is not given there, then I use a T test. Okay. So next time when I see you, I hope you come out with more questions for me. If you have really finished your chapter test and or homework questions or any mistake coming from your chapter or your test 3, you should keep it, right?
Yeah. Well, I
Keep a
have to just
picture.
repeat. If
Yeah.
no sigma, use the T test, and with sigma, use the Z test, right?
That's right. Keep this one in mind.
Yeah.
Then you should do right because the calculator will help you step by step, ask you to enter simple mean and sigma, and that's it. Okay. And for the t-test, we ask you what is your null hypothesis and what's S bar. They will kind of step by step for you to enter the data. Same thing. Okay.
Okay. Thank you,
Okay.
Professor.
You're welcome. So remember this, and if you have more questions, just post on the discussion board that our state 1000 there discussion board. Okay.
And this video will also be on top it with the discussions, right?
This video I will put in the 96 because this is belong to our program of the 96. The 96.
Okay.
Yeah.
Number C. Discussion 96.
Yeah. The discuss either week 11 Zoom meeting or post there later. I need to upload it to the YouTube and modify and editing and post that. Yeah, it's still a lot of
A
work.
lot of work.
A lot of work. Yeah.
Okay. Thank
Okay,
you.
so hope you do well on your coming test 3. Okay.
Yeah, but that's just a test, right? But we can use our notes, correct?
Oh yeah, you can use note and do. If you start earlier, you can start earlier. Take 2 hours, 3 hours to do it.
Yeah, but that's going to be a test for the all day, right, Professor?
Huh?
It's the test is all day, right? Or is it only a
Yeah. Test is now it's open. You can start doing
Yeah.
tomorrow or until Monday,
Wow.
right? Monday will be
Okay.
the deadline and cut no more. So you have a lot of day for you to do one test. But
Thank
that's
you.
just for you to practice learning, okay? And if you come out with any questions, you can put on the discussion board, okay?
Thank you.
Okay, you're welcome. All right, so hope you work out the chapter 8, chapter 9 homework first, okay? And from the homework, you will discover any questions. And those homework questions, usually the computer system will select the homework question to become your chapter 3, not the chapter 3 test, that we call test or quiz there. It's selected from your homework. So if you finish the homework, you should be able to do that part. And that's why if you form the homework, it came out any question you don't know or you made a mistake there, post on the discussion board. Okay, you can copy and paste there. This program, the good thing is you can copy from the homework directly, copy and paste into our discussion board here. It is acceptable, and you don't need to really take a picture. But some people taking a picture, then post there. That's okay too. But I tried myself, just copy and paste. You can go there. And you can even copy and paste your wrong answer there so people will understand where you made a mistake. So we can help you to make a correction. Then you can learn more, better. Use your own example. Okay? All right. So I know some people need to move on to another Zoom, right? So it's 6 o'clock. Our time up now. And just do this way and do well on your coming one. And we have just one more online test, and you will go to the final. And so after the quiz, after the Thanksgiving, it's very quick to move on to the final exam. So that's why take a good use of the time, okay, for your November before the Christmas time, before the final exam. Well use your time for study this, because if you use well, you will do very well, and by the final exam you can do very well. Okay. In the past, I have students that they studied the midterm exam with a kind of 55% only, but the final got a 95%. Then I just gave her the A, right? Because
Yay!
yes, because progress, right? Become the
We need that,
90%.
Professor.
Yeah, so even the midterm didn't do well, it's okay. It's done, it's gone.
Well, no, like you said, that break will be the best time to study.
Yeah, and you're going to have break the Thanksgiving time. Just tell the family you don't join the cooking anything. Use that time to study. That's more important.
No,
Study
I do
and
Christmas and my sister-in-law does Thanksgiving, so
oh,
I just bring a pie and a ham.
that's
So
right.
good.
Bring something ready-made.
Yeah.
Save the time. Yeah, that's right. And then we can celebrate the Christmas time, right? After the final exam, Christmas time celebration. Okay. All right. So everyone study
Thank you.
well.
Have
So
a good one.
you're welcome, Kiara, Jessica.
Thank
And
you.
yeah,
Thank
Bye-bye.
you.
you're welcome, Bodas. And
Thank you.
you're welcome. And see you next week. Yeah, next week we still meet before the Thanksgiving. Yeah. Bye-bye.